All right. Good morning, everybody. Welcome back to Comp 2452. If you're watching on the stream today, I don't know what the heck is going on with my webcam, but you're going to look at me this way today. So, and if you're here watching this later, hello, I guess. I hope you're all having a good day today. It finally feels like it's warming up, and so I'm happy about that. We're getting real close to the end of classes. So I'm happy about that, and I'm sure that you're all very happy about that as well, as we're getting towards summertime. It's not April Fool's anymore, but our cookie clicker is still in banking season. So it switches to Easter season, and the golden cookies turn into to Easter bunnies. They turn into rabbits. And when you click on the golden cookies that are now rabbits, they will sometimes drop egg upgrades, as rabbits are wont to do. But everything has changed about this interface. Like, we don't have grandmas anymore. We have rolling pins. We don't have bakeries anymore. We've got ovens, and we don't have, this is farms, I think. We've got kitchens now, where everything has kind of changed about this. The temples here, I think these are, oh gosh, I think these are secret recipes. I think. Maybe not. Are they likes? They're likes. We can't get 100 likes here. Oh. So we'll just buy some upgrades. And then what I think I'll do is maybe at the end of class, we'll ascend one more time to see that part of our game. Although we won't be able to buy any more upgrades because we won't have any more legacy points yet. Let's actually talk about the course. So what I want you to be able to do by the end of today's lecture is we're going to take a little bit of a circle back and look at something that we've already spent some time looking at here. What I want you to be able to do by the end of today's lecture is model relationships between data and between data model objects in a database. And the very specific thing that I want you to be able to do by the end of today's lecture is to use transactions in a database. This is something that I kind of intentionally skipped over when we were looking at SQL in the first place. But we've got a little bit of time here, and so I want to take the time to actually take a look at this idea of transactions. One of the things that you will see as you go forward with databases stuff and databases classes are that databases and other systems courses start to have a lot of concepts in common with each other. Transactions here are one of those places where you're going to see that databases and things like operating systems have common ideas that are shared across these things. I would go as far as to say that databases and relational database management systems really are operating systems, just not in the same kind of way that we use operating systems. But ultimately today, what I want you to be able to do is I want you to be able to use transactions as part of SQL queries that you're writing. We are getting very close to the end of the course, and so I wanted to give you an idea of what to expect next week. In class next week on Tuesday, my plan is for us to talk about the final exam and then just kind of have a course review, course overview, kind of like the things that we've done so far in this course. Thinking about where we came from in like Comp 1000 level courses, what we did in Comp 2450, how we got to here, and then where you can expect to go after this course. I've tried to build that in a little bit with some of the topics that we've seen so far, but I want to spend some time taking a look at that again. And then on Thursday, there's no lecture. I'm going to be in this room, and I'll be in the afternoon classes room as well, but I'm not lecturing. I'm just going to sit here, and if you want to come talk to me, like open office hours sort of thing, please feel free to come and talk to me on Thursday next week. But there's no lecture. There's no new course material for Thursday's class next week. With that, I promised to give you some time to ask some questions about the project. And so I'll hold this up for a couple seconds, and then I will switch over to Mentimeter. Yeah.
I have a question on Tuesday. Like, should we expect to get a list of learning outcomes like last semester?
You can expect to see a list of learning outcomes before the final exam, yes. Yeah. I'm not going to have it ready for Tuesday, but you can expect to see that before the final exam is published, yeah. Okay, I'm going to switch over to Mentimeter here. I'll let you answer this question first. I'll give you 30 more seconds because I think this is a really important question. Okay. Dino, okay. I mean, blue is the cutest hat. I don't know. I think blue is the cutest hat, but Dino is the one that I worked the hardest on, and that's the most use it ever got, was Walter sitting inside of it. This was a costume that I made for my kids for Halloween, just out of boxes, like a Dino box costume, and the most use that this ever got was Walter sitting inside of the head, which was, I don't know, it was nice. Here's my next question. I do want to spend a little bit of time doing review next week, and so I want to give you a chance to give me a sense of what you would like me to prioritize for review in class on Tuesday next week. This is kind of a list of all the different topics that we've covered at a high level throughout the term. I'll give you about 30 to 60 seconds to answer this question. And then I'll have it recorded on Mentimeter. Okay, all right. I will try to structure my review class so that it matches approximately this order of stuff. I can't promise to get through everything in the review class, but I'll try to order it this way for you when we're taking a look at that next week. And with that, ask me questions. Any questions that you've got about the project? Any questions that you've got about the course? I'm also happy to answer questions verbally if you have questions in the room right now. Is the program to train the Markov chain in the root of the project or in a completely separate program? So like a completely separate folder. You can safely put this like either in the same project folder that you've got already. So just have like a training folder that's in there right beside source. You can put it directly in the root. If you want to put a .py file inside of the root directory of it, that would be fine. I don't really necessarily want this to be a completely separate program. Like I'm not looking for you to submit two high-level folders, one that is your web app and then one that's a separate folder. You can just put them all in the same folder if you want. You don't have to have them separate. That's a good question. So I can't promise to get this to you before the end of classes, but I promise I will get these to you before the final exam, and I will publish the grading guide in advance of the final exam so you have a sense of what I was looking at for that. Where do you pass the Markov model to? This is a good question. Something like this was asked on the discussion forum. I'm looking at my watch because my dad is calling me right now. He doesn't know what I'm doing. My dad's calling me right now. And I'm not going to answer him because I know what he wants. The Markov chain and the Markov model, these are implementation details of your domain model. And so my expectation here is that really, in some class in your domain model, something that's going to have some responsibility for doing the buying of things, that's going to have some kind of internal Markov chain, either as a class, like you make a full class that represents this Markov chain, or alternatively, you've got something like just a static variable that's constant, that this represents the transition matrix that you've got for this Markov chain. This isn't something that you should load into your view in any way, shape, or form. This should go directly into your domain model. And the place where I'd expect you to load this is in approximately the same spot as where you've got like the create DDL stuff going on. So in main.ts, once you've loaded your database, then the next thing might be to load the transition matrix somewhere into your domain model as a static method so that you can use that across all instances of the classes that you've got. The hidden picture was not Walter, no. I know that somebody posted on the off-topic discussion forum what their strategy was so far. That person's strategy is they're thinking the right things, but they're not on the right path. They're not on the right path. That's how I'll answer that. But it's not a picture of Walter. One more small hint. No, I'm not going to give you another hint. Okay. Same thing. So I'm going to give this to you before the final exam. I can't promise to give it to you before the end of classes, but definitely before the final exam. Same thing, before the final exam, but not before the end of classes necessarily. Yes. So that's a good general idea, a good general overview of what's expected. So you'll have this program that you run in the command line. The output from that program is a CSV file, and the CSV file would contain like your transition matrix that you've constructed as a result of going through that training data. And then this is going to be the input that you're using for like when you're starting things up. So again, right alongside where you do the DDL thing, so you've imported your create tables.sql as a raw string, you can import the CSV file as a raw string and then load it into your domain model classes for that. I'm going to answer more questions about the final exam on Tuesday next week, so I'll give you another chance to do this. But generally, the idea is that you could expect the structure of the final exam to be consistent with what you've seen for the two-term tests that we've done so far. But again, I'll talk more about this next week. Even Walter stole my lunch. Okay. I hope that it was a good lunch for Walter's sake, and I'm sorry that Walter stole your lunch. Whoa, that's a good question. I don't know. I'm not sure. Like maybe this is a secret I want to carry forward into further classes, and I'll just find out how long it goes. But yeah, I don't know. What do I think about them? I'm not really sure how to interpret this question. So like the computer systems course, this is digressing, gonna make sure we've got time, digressing a little bit. The computer systems course, like we kind of taken 2 systems courses and reduced it down to 1 systems course at the 3000 level. That's effectively what's happened with the 3rd year courses. So if you're in honors, you would have previously had to have taken Comp 3370 and Comp 3430, so operating systems and computer organization. But now you have to take that course, just that course. So there's now only 3 credits at the 3000 level that you need to take for systems. The theory of computing course, I guess I don't really have much of an opinion on that class. I'm not a theory person. I've never been a theory person, and I will almost certainly never be a theory person. That's just not what I'm interested in computing. So I don't know that I have much of an opinion on that course. But what I can say about the systems course is that we've kind of reduced the surface area of what you need to do at the 3000 level for systems courses. So I think that's a good thing. And then we've moved some stuff from the 3000 level courses up to 4000 level. So now there's going to be Comp 4280, which is a 4000 level operating systems course. And that's a course that I'll be teaching next winter. So if you're there in next winter term after this one, maybe I'll see you then. All right, I think that's all the questions that I got here. So thank you for asking those questions. Like I said, I will give you a chance to ask more questions about the test, about the final exam specifically next week. I'm going to remember this for sure. I'm going to leave these results for the afternoon class too, so that I can get an overall high-level picture of what everybody thinks the best hat is. And with that, let's move on and start talking about transactions. So, a lot of you have seen this already in the projects that you're working on. And that is that, well, I mean, all of you have seen this in the form of writing programs at any level. Some abstract operations require more than one step. I think we can agree on that. I'm going to give you an example of this. Inserting a new node into a list is more than one operation under the hood. It's one big operation that we're doing, but there's many steps that are part of that. I have to create a new instance of a node. I have to set some nodes next to be able to put it into the list. There are several steps that are happening as a result of this one big abstract operation. Some abstract operations require multiple steps. Here's another example. We've got that battle scenario in Pokemon, and at the end of the battle, the trainer that lost the battle has to give some kind of money to the trainer that won the battle. There's some kind of a transfer that's happening between these two trainers. And there's one operation that's happening here. I'm conducting a transfer between these two trainers, but this requires two different steps. One, I've got to reduce the loser's balance by some amount of money. I have to take money away from them as a result of this transaction that's taking place. And the other is that I have to increase the winner's balance by that same amount. So to do this whole abstract operation of transfer money between these two trainers, I've got to take these two separate steps. And these are completely independent of one another. I have to do these two different steps to accomplish that task. When we're thinking about this in SQL, and when we're thinking about writing software to do this, there are a couple of problems that we're going to run into as a result of this idea of things taking multiple steps to accomplish. One is that sometimes SQL statements fail. I'm going to ask, just by a show of hands, how many of you had a SQL statement that failed the first time you ran it? Everybody should put their hand up right now. Yeah. Sometimes SQL statements fail. Sometimes it's because of us, like we wrote the wrong thing. Sometimes it's because of other stuff that's happening in our system. Sometimes it's stuff that's happening outside of our system that we have no control over. But sometimes SQL statements fail. Some abstract operations require multiple steps. So the two examples that we've seen so far are like transferring money between trainers here and doing something like inserting into a linked list. These are one abstract operation each, but they require multiple steps to accomplish those abstract operations. Sequences of SQL statements. So SQL statements themselves are, when I'm thinking about this is like insert or create or update or select. Sequences of these statements are not atomic. And I want to focus on this word atomic. Just quick show of like thumbs up. I know what the word atomic means in the context of computing. Thumbs down, I don't know what this means in the context of computing. Okay, lots and lots of thumbs down. Okay. So the idea of atomic and atomicity is that an operation, some operation, it either fully happens, it completes all the way to the end, or it doesn't happen at all. There's two states here. It's either atomically completed as one single unit, it's fully done by the end of it, or it never happened in the first place. Those are the only two options that we have for something to be an atomic operation. And so I'm going to ask you some questions about some statements. These are code statements. And part of what I'm asking you to think about is to relate this to other courses. Thinking about Comp 2280 specifically now in my head, I want you to make this decision if the statements that I'm going to reveal to you are atomic. Do they complete or not complete, or can they be in a half-completed state by the time you're finished running this line of code? And I want you to give me a thumbs up and thumbs down, and I will count down to make sure that we're all kind of on the same page here about when to do that. Here's the first statement. X equals 5. And then I'm gonna count to 3, and then on the beat after 3, I want you to give me thumbs up, thumbs down. This is an atomic operation. So 1, 2, 3. Okay, good. Lots of thumbs up. Now I'm going to politely ask you to shout to me. What is the instruction that would happen here? If I were to compile this into LC3, what's the instruction that would actually happen here? Same thing. On the beat after 3, so we don't all have to do it together. No, so that we do have to do it together. Yeah, so we do have to do it together. What's the instruction? Okay, ready? Are we ready? Okay, 1, 2, 3. Load. Okay, thank you for saying store. You're on the right track. You were absolutely on the right track, but load. Yeah, this is a load operation. The load either happened or it didn't. I either have 5 in my register or I don't. This is an atomic operation. Even when we're thinking about statements in a programming language, when this statement has completed, I either have 5 in this variable or my program has crashed. That's basically the only 2 options that I've got here. I have this value loaded into memory or I don't. Here's another statement. I'll let you think about this for a moment. We're going to do the same operation. Okay, thumbs up, this is atomic. Thumbs down, this is not. On the beat after 3, 1, 2, 3. Okay, good. Lots of thumbs up. Lots of thumbs up. Now, instruction. What instruction is actually happening here for this specific thing? On the beat after 3, 1, 2, 3. Add. Yes, excellent. So this is going to do one single thing, and after that add instruction is executed, it will either be 7 in the register, or it just won't have changed the register at all. It will still be 5. It will either be done or it won't be done. It's never going to be 6. It won't be 6.5. We're not going to be in this weird state where we've got half of a number updated as a result of this. Okay, think about this. Same thing, beat after 3, thumbs up, thumbs down. Is this atomic? 1, 2, 3. Okay, so now we're getting a mixture of thumbs up and thumbs down. Good. Thumbs up or thumbs down? Yeah, okay. I'm going to ask you now what instruction this is, keeping in mind that I don't know LC3. One, 2, 3. Good. There was just like this wild range of different answers here. Yeah, good. Okay, so this is 3 instructions. This is 3 instructions. This is a load and an add and a store. This is 3 instructions. X++ by itself is not atomic. If I have 3 instructions here that are getting executed, all 3 of them independently are atomic. I will either load or I will not load. I can't be in a half-loaded state. I will either add or I will not add, but I cannot be in a half-added state. I will either store or I will not store, but I cannot be in a half-stored state. Same question. Is this atomic? Okay, thumbs up, thumbs down, beat after 3. 1, 2, 3. Good. Lots more thumbs down. These statements are the same. This is the same statement. This is the same sequence of 3 instructions. Load is an atomic operation. Add is an atomic operation. Store is an atomic operation. But this whole sequence, I could get halfway through it and then I can be interrupted. I might load and then I'm interrupted and then I can't finish the rest of it. I've done half of this instruction, 1/3 of this statement. I can do load and I can do add, but then I can get interrupted before I do store. Now I've done 66% of this statement, but I haven't completed the whole statement here. Here's my last question. Thumbs up, this is atomic. Thumbs down, this is not. 1, 2, 3. Good, lots of thumbs down. This is not an atomic operation. This is functionally the same as these other 2 statements that we've got here. But now it should, I hope, be quite clear. that while this part might be an atomic operation, as we saw up here, x plus 2 is atomic, x plus 1 is atomic, assigning the result of that back to x is no longer atomic. There's at least 2 steps that are happening in this. There are at least 2 steps, and there are typically 3 steps that are happening here. I've got to load this into a register, add to that register in place, and then store the result of that register back to memory. So these statements, some of them are atomic operations, and some of them are not. And the places where they are not atomic operations is where they really kind of break down into multiple steps here. In SQL, a statement is an atomic operation. This is a promise that is made to us by our database management systems. Anything that is within a single statement, so a select, an update, a delete, or a create table, anything that's there up to our semicolon, this is an atomic operation. The entire statement will be applied or it will not be applied. There's no half-applied state for the statements that we've got in SQL. So that means things like inserting into a table. This will either be fully inserted or it will not be inserted. There's no circumstances under which the Pokemon table will have like just Totoro inserted here as a column value with nothing else. There's no situation where that's going to happen. Updating my Pokemon table, this would target one specific row, but same thing. It's either going to fully update this thing, that one row by itself, or it will not do it at all. This statement will fully run or it will not run at all. And if we update all the rows in a table, like this one, Walter's stealing all the Pokemon to put them on his team, this will either run to completion or it will not run at all. If there's 5 million Pokemon rows in this table, they will all be changed or none of them will be changed as part of this operation. Updating 5 million or 5 billion rows takes time. An observable amount of time from our perspective as humans. This would just take a while to run this query. But if our database management system is interrupted in any way, shape, or form, it will either be completed or it will not be completed, and it will just be in the original state that we were in. So it's like it never happened at all. Only one of those 2 states is going to happen here with SQL. Interruptions, I'm being kind of vague about this, but this can be things like connection problems. At least in our course, this is a non-issue because we've got the entire database management system fully inside of our web browser. There isn't a connection, but in practice, if you're using web applications that are relying on some external database service, you've got a network connection to that thing. So like, not Wi-Fi in a data center, but somebody comes and cuts your network cable. That is a network interruption. The firewall shuts off for some reason. That's a network interruption that might be happening. Like companies like Cloudflare go down or Amazon goes down. That's a network interruption. This is a connection problem that you could conceivably have out in the real world. For us in this course, that's not a problem because, again, we're fully contained within the environment that we're in. We're in our web browser. We don't have a connection to the database. So we don't really have to worry about that here, but it is a real problem to have. Programming problems. So like, I'm going to step through writing this code, and we've all put our hand up to that point. We've written something wrong, or my user has asked to insert something wrong. Trying to like insert a duplicate username into my table, and a constraint violation comes up as a result of trying to execute some SQL query that I've got. Or we've got hardware problems, and this is maybe more realistic in the course that we're looking at right now. You're in the middle of running some kind of a SQL query, and late nights, we're trying to keep ourselves up and drinking energy drinks and coffee and spilling all over our laptop. More than once this term, I've had this water bottle on my desk in front of my laptop, and I reach over and I have actually just spilled on the keyboard, which is not connected, but I've spilled on the keyboard, and this is a real problem. It's an actual problem. People in data centers don't typically walk around with copies like to trip and spill on the servers, but this is a real problem. Fire burning down our building, the power going out in our system. These are all realistic problems that could actually happen in a real world environment. So when I'm thinking about interruptions and I'm thinking about this idea of statements that are not atomic, so going back to our code examples, this would be like I get through the ads, I get through the load and I get through the ads, and then the power cable is unplugged or starts burning on fire here. While individual statements in SQL are atomic, sequences of statements in SQL are not atomic. Our first statement here will either execute or it will not execute. The money will either be removed or the balance will stay the same. Our second statement will either execute or it will not execute. We will either add the money or we will not change the balance at all. We're not going to be in some half-changed balance situation. But these two statements independently are not atomic. This is not one atomic operation. And so if I was able to change the balance of my first trainer, I will have removed money from them. And if I were interrupted while the second one was running or before it even started, but after the first one, that will never happen. And so at that point, I will have taken money away, but nobody got any money as a result of that. These two statements in sequence are not atomic. There can be an interruption that happens in the middle of them, and we can get some situation where we've lost money as a result of that. In this example, if we get interrupted after our first statement, we've lost some money, and were we to be doing banking applications, that wouldn't be a good situation to be in. But I'm going to add one more word here. So we've got atomicity and atomic. Now we've got this new word that I'm thinking about here that is consistency, but now in the form of data consistency. This is not really the same as the heuristic that we were talking about before, other than they share this common word. Data consistency here to me is if we have multiple different places or multiple different instances or data structures that are referring to some common thing. They're all referring to some common thing. Data consistency is that all of those things that are connected to the same common element, they should all agree on the same values. So one abstract idea of this is if we have a linked list structure, and in the linked list structure, we have a node count. A linked list structure can have data inconsistency if the count value that's in node count, this integer, doesn't actually add up when we were to count all of the nodes. Our data structure has data inconsistencies at that point. We've got two values that are about the same thing, but they don't agree with each other. We have two different values here. Another way to think about this is where we've got two tables for our Pokemon team. And we've decided that counting the number of Pokemon that are on a team is too expensive of an operation. So I want to show this high-level overview of how many Pokemon are on my team, but it takes too long to go through and count them all, load up all the Pokemon and then iterate over them or ask that data structure to tell us how many things are there. So we're going to track Pokemon on our team in two ways. We're going to continue to have an array of Pokemon. We're going to have this foreign key on our Pokemon table that refers to trainer, but we're also going to add this column that's called count. And so we're going to be able to select from the trainer and then just have this kind of pre-computed count value. If we're doing that, and we've got a table structure that looks like this one, then catching Pokemon, when I'm adding a new Pokemon to my team, it now takes two steps to do it. This is still one abstract operation, but it's going to take two different statements to accomplish this task. I've got to increase the number of Pokemon that are on my team in the trainer table, and then I have to actually do the insertion here. Again, these two statements themselves are atomic. We will either increase this value or we will not. We will either insert this row or we will not. There's no halfway here. We're either going to do one or the other. But across these two statements, they are not atomic. The sequence of operations itself is not atomic here. And so that means that if I were to be interrupted after that first statement, my data will become inconsistent. I'll have two places that are referring to the same information, but they disagree with each other. One of them has a count value. It will have been updated, but if I were to count the number of rows in the table that correspond to that value, it's not the same. And this is because we have been interrupted in the middle of this non-atomic sequence of instructions that we've got here, or sequence of statements that we've got. Some abstract operations require multiple steps. Some abstract operations require multiple steps. Sometimes SQL statements will fail for reasons that we've talked about. Programmer error, plugs being pulled, water being spilled on our laptops. Some abstract operations require multiple steps. Sequences of SQL statements are not atomic. And so what we really want to do is make them atomic. I either want to apply all of these statements or I want to apply none of them. The statement itself is atomic. It will either be applied or it will not be applied. But now what I want to do is the same thing, but for many statements. I want to apply all of these or I don't want to apply any of them. We've got two parts to this. We add a statement to our code that is to begin a transaction. Before we do any of the statements that we would want to do in this atomic operation, we just enter the command in SQL, begin transaction. This is sometimes shortened even as just begin because it's a common enough operation to want to do. Then we do all the stuff that we want to do, and at the end of that sequence of statements, we will commit the changes. Anything that happens between begin and commit is atomic now, fully atomic. All of the statements will execute or none of them will execute. Yes, this. They're all atomic. The entire sequence is going to be made into one single atomic operation. They'll either all be applied or none of them will be applied. What I'd like to do is spend a little bit of time in a REPL kind of taking a look at what this is. You're going to have to forgive me for contriving like issues with our database by hitting refresh on the page, but this is what's going to simulate pulling the plug on the database system that we've got. I welcome you to follow along with me if you want to. I'm going to be using this REPL. This is on the PG Lite website. This is what we started with way back when we were thinking about initial database stuff. And what I want to do is I kind of want to get ourselves set up with this. So to begin with, I'm going to create a table that represents our trainers. They're going to have a name. This will be our natural key for our trainers. And we're going to say that our trainers have a balance. The type for this is going to be integer, and it's going to also be not null. You have to have some balance to start with here. So I'm going to create this table that represents the trainers that we're going to have in our system. We've got this name. This is our natural key on our table, and we've got a balance. You have to have a balance as part of being a trainer in the system that we've got. I'm going to insert a couple of trainers. And I'm going to give our trainers 1,000 units of money by default. So this will give us something to start with. Mom is sending us out as 12-year-olds into the wild with $1,000 to go and like find random folks on the road to battle with. Mom says, "Goodbye, Franklin. Goodbye, Walter. Here's your $1,000. Go live your life." Yeah, that's where we're at in our game here. And we're going to say that, we've got a heated battle. we're going to say that Walter wins. So like mom has kicked us out. Here's your $1,000. We get outside the door and Walter's like, hey, you want to battle? And I'm like, yeah, sure, let's battle. Walter wins. And so we're going to start having to transfer the money between the two of us. The transfer of money between the two of us is going to be those two update operations. I need to remove money from me, and then I need to add money to Walter's account. Those are the two operations to complete this one abstract operation. So I'm going to remove the money from me first. I'm going to say update trainer, set balance is equal to balance minus 100. So we bet $100. Mom's kicked us out. We're standing right outside her house. $100 says I can win, and Walter wins, so I'm going to lose $100. I'm going to set my balance to be 100 less than it was, where name is equal to Franklin. So I'm going to remove 100 from my balance. Okay, and then we were interrupted. So I'm going to hit refresh on my page here. I'm going to reload this browser. This was I don't know, like a gaming system that we're playing this on. The power went out and I've lost the money. And if I select star from trainer, so I get all the records from trainer, Walter didn't get his money and I've lost money here. That's the end of this kind of situation that we're in. We've lost power in the middle of this transfer operation. So I'm going to set us back. We'll rewind here. Just before we do this battle, we've still got our $1,000 each. Mom has just kicked us out. She's maybe put some lunch in a bag for us, but go live the rest of your life with this $1,000. We do this battle again, but this time we're going to start to have a transaction that happens. So I'm going to say begin transaction. We get no output here because all we're really saying is, I'm going to give you a bunch of statements. And I want these statements to all be applied, or I want none of them to be applied. And so now I'm going to say, all right, we had this battle. Update trainer, set balance is equal to balance minus 100. We're back in the same state that we were in. I'll select star from trainer here. We can see that this operation has been applied. But now, beginning of game, wild Nidoran comes in and like knocks us over. And now we've kind of like been interrupted in the middle of doing this operation. Refresh my page. If I select star from trainer, nothing has happened. The sequence of statements that we had were never committed to the database. I never finished the transaction that I want to do. So in this situation, what has happened is that none of them have been applied. No statements have been applied as a result of this. I can do the same thing here. So begin transaction. I can update. I can do this operation to remove the balance from myself, and then I can do the opposite for Walter. And I can select from trainer. The transfer has happened, but we got interrupted. And if I select star from trainer again, nothing has happened. I've got two statements here. None of them have been applied. The sequence of statements that are after the begin transaction will either all be applied or none of them will be applied. And in this case, none of them have been applied because I haven't said I'm done. So we'll do this one more time. We'll begin a transaction. We'll update trainer, set balance is equal to balance minus 100. Name equals Franklin. We'll do the same thing for Walter, but we'll increase his balance. We'll select star from trainer. We can see that those changes have been applied as far as we can see right now. And then we'll commit. So Walter has like taken the money, put it into his wallet, and he's got this saggy little belly that flops beneath him as he runs. He puts his wallet back in his pocket. and I put my wallet back in my pocket, and the Nidoran comes and knocks us both over, and we're interrupted. But if I select star from Pokemon here now, trainer, sorry, the transaction was applied. The whole thing was applied. So we began the transaction, we issued some statements, and then we committed the transaction. The whole thing was applied in this case, not half applied, it was all applied. Does that make sense to everybody? Okay. I'm hoping that you can start to see some operations in your own code that probably need transactions. Again, these are things we don't really have to worry about in the context of this course because like your battery dying is the worst thing that could happen in the middle of something, but this is a real thing that you might want to have. I'm not assessing you on this and your projects this term, but it's something that you realistically could have in the stuff that you've got. I want to try do a couple of other things here. So I'm going to do this. I'm going to start doing what we tried to accomplish in the slides. Right now, my trainers have two columns. They've got a name and they've got a balance. But what I want to add to them is I want to change this table so that I've got a new column in it. When we were doing this before, we dropped the table and then just recreated it. But I'm going to say that we've got data in our table that I don't want to lose. This is a really important battle that Walter and I have had, and we don't want to lose this transaction that's taken place. And so I'm going to change my table. I'm going to change my table to have a new column on it. And the way that I'm going to do this, I'm not going to ask you to do this in any place, any way, shape, or form. I'm showing you this so that you are aware that this is something that we can do. I'm going to say alter table. I want to change the definition of the table that we've got. I want to alter the table that's called trainer. And what I want to do to that is I want to add a column. So change the table definition for trainer. I want to add a column to it. The column that I want to add to it is going to be called team count. It's of type integer. So this looks a lot like what we had with the initial DDL that we had, the create table statement. I want to add this column that's called team count. And I want it to be an integer, and I want it to be not null. I'm going to run this. This won't work because we already have rows in this table. And the rows don't have a value for this new column that we want to add. I've said that it can't be null, but these rows exist, and I don't know what to give them if it's not null. So I'm going to run this command again, but the difference I'm going to make to this is I want it to be an integer, I want it to not be null, but I want it to be defaulted to 0. So I want to provide a default value. When I insert a row into this, I want the value for this to become 0. I'm going to run this statement now, and this is going to work. And if I select star from trainer, then I've got this team count. Now, importantly, the two statements that we've got there, those alter table statements, they either run to completion or they do not run at all. So the first alter table that we had there, it's not going to be in a state where we've added this row, but we haven't given any values for that. It just forbid us from doing it in the first place. The second statement that we added, where I said, hey, you should put a default value of 0 here, this runs to completion. Every row has this value now by the time that this statement is completed. It will run to completion. This is one atomic operation that we have here. I'm going to add a new table to this, create table, Pokemon, and I want my Pokemon to have a couple of columns. I'm going to say that they've got a nickname. This is going to be a varchar 255. It's going to be a string. I'm going to say that this should not be null, but I'm not going to say that this is a natural key. This isn't something that should be unique. Different Pokemon should be able to have the same nickname as in the system that we've got. They should be owned by a specific trainer. So I'm going to say that they've got a trainer column that has the same type as the natural key that we've got on our trainer column. Same thing. You must be owned by a trainer, but it doesn't have to be unique. The same trainer can own many different Pokemon in the system that we've got. I want to make sure that there's a connection between these tables. So I'm going to say foreign key trainer references. I'm going to put parenthesis around this. References the table trainer, and the specific column that it's referencing on table trainer is the name. I'm going to hit enter here, and now we've got this Pokemon table that's got two columns. We've got a nickname and a trainer, but we don't have any Pokemon in this operation, in the table yet. I'm going to do this twice. I'm going to start to catch a Pokemon. We're going to update team count and insert into Pokemon. These are the two operations that we need to do to catch a Pokemon in the system that we've got now. I'm going to begin a transaction. I've got two statements that I need to run that I know are going to be an atomic operation that I want to complete in sequence, but they themselves are not atomic. I'm going to say update trainer, set team count equals team count plus 1. So increment team count. Oh no, I've just given everybody a Pokemon, but I'm only going to insert one. I'm only going to insert one. Okay. No problem, because we're in a transaction. If I abort, then I haven't changed anything. I can stop the transaction from happening. I can, refresh my page, but do a command to refresh this page. I want to stop the transaction. In about 5 years, when you all have jobs, 6 years, when you all have jobs and you're out there working and you're working with a database, I think it's a rite of passage for junior devs to try to change something in a production database. I've been there, I've done that. That was a bad choice. I did not start a transaction, for the record, but it was fine. It was fine. Nobody knew. It was fine. This is a rite of passage. Now you all know that you should start a transaction before you start to do prod database changes. You shouldn't be in that position in the first place, but start a transaction so that you can abort your transaction if you mess something up. Okay, so I'm going to begin a transaction here. I'm going to begin a transaction, and I want to do that abstract operation. I want to catch this Pokemon. And so I'm going to say that I want to update this for a specific place where name is equal to Franklin. I'm going to catch this Pokemon. So now if we select from trainer, we will have updated just me at this point. And I'm going to insert into Pokemon, and the values that I want to insert are nickname and trainer. And I'm going to say that we've got values, Snorlax, and Franklin. So at this point, after I've done this insertion, select star from Pokemon, I've got two data structures, my two tables, that have data consistency. They're both talking about the number of Pokemon that I own, and they are both consistent with each other. Team count says 1. The Pokemon table says that there's one row that has this specific trainer's name for the foreign key. The trainer table says that Walter has 0 for their team. The Pokemon table says there are no rows that have Walter as the trainer in them. We have data consistency between these two tables. And so here, I'm going to say commit. I want you to take those changes and actually apply them to the database. So I'm not going to stop in the middle. I'm going to actually make those changes as one atomic thing to the database that we've got here. All right. The other thing that I want to talk about with regard to transactions is that, I'll get to you in just a second. Yeah. Sometimes we can find ourselves in a situation where we have sequences of statements that will require us to temporarily violate referential integrity. An example of this in my head is I've got a one-to-one relationship between two different classes, and I have two tables for those two different classes, and both of them are using IDs that are generated by the database, so they're both serial. In order for me to do these insertions, I'm going to have to insert one and get its ID, but have the foreign key for the other table be null, insert the second one, and then go back and update the first one again. But in order to accomplish that sequence of steps, I have to be able to violate this referential integrity. I must be able to do that temporarily. And so one way that we can also use transactions here is to temporarily disable these foreign key constraints. I can temporarily say, it's fine, I'm going to do this. It's fine, I'm going to do this. And then when I try to commit, you should check and make sure that we have consistency with the constraints that we've got in the tables that we've got. Yes?
Yeah. So more specifically, how these like SQL transactions works? Like when we begin the transaction, are we like directly working with the main database, or it kind of creates like a copy underhood and like?
Okay, so the question is kind of like, how does it work under the hood? I need you to take a fourth-year operating systems course to really get the idea. Your intuition of like it's making a sort of copy under the hood is approximately right. Yes, it's approximately right. It's more like what happens is that the database system will start to make changes to its internal state in such a way that it's able to recognize that something should be fully completed or it's only halfway done. And if it's able to recognize that it's only halfway done when it starts back up again, so when I hit this refresh on my page, it reloads the database. If it sees that this is in a half completed state, it will just not do anything. It's just going to remove that thing from its kind of record of transactions that are going to take place. If it sees that it was fully complete, then it will apply it. It might try to continue to apply it if it's necessary, but it will apply it to completion. This is a concept related to file systems and operating systems. So when you get to 4280, we'll talk about that. Yeah.
Like, is it possible also to make that table check for its consistency by itself? Do we have to track that?
Like checking for its consistency in terms of across tables. Yeah. So like when we've got this team count, and when we've got from Pokemon, we've got data consistency between these two tables. It's possible to do that, sure, but it kind of relies in some cases on, again, vendor-specific things. So what we're going to be talking about right now in this moment is something that is kind of vendor-specific. You have to do different things for different database management systems. It's the same kind of thing with this idea here. Yeah. Any other questions about this so far? Yeah.
Sorry. We did go over like how to verify that the data between the two tables is consistent.
The way that so that was this question here. You can possibly do that across tables, but it's going to rely on kind of vendor-specific tools in certain cases. So the way that you'd accomplish that with Postgres might be different than the way you accomplish it with SQLite, might be different from the way that you accomplish it with MySQL. There are some things in SQL, the language, that will accomplish these tasks, but even then across tables, it's a little bit more difficult to do that beyond the kinds of basic referential integrity stuff that we're setting up here. So for us, the way that we're going to accomplish that is really just externally, we're going to know that this should be applied as one atomic transaction as opposed to multiple steps. Yeah.
Can you run more than one transaction at a time?
Yes, so the question is, can you run more than one transaction at a time? It's possible to do things like having nested transactions, yes, but I'm going to say that that's far outside the scope of this course, yeah. Okay, so the last thing that I want to talk about here is, yeah, disabling these foreign key constraints temporarily for a specific transaction that you're trying to do. So I'm going to go back to here, and what I really want to be able to do is I want to insert into my Pokemon table a nickname and a trainer. And the values that I want to insert into this are Fire Moon, and this is my kid's Pokemon. So I want to insert that this is for that specific trainer, but they don't exist yet. There is no trainer in this system that has that name yet. I'm contriving this scenario to be very clear. Like, we would do this in a different order if we were actually writing the code to accomplish this. I'm just trying to demonstrate the idea of disabling these foreign key constraints temporarily. So what I want to do with this is I want to change the definition of my Pokemon table. And what I specifically want to change about the definition of my Pokemon table is that when we created this table in the first place, we said that the trainer is a foreign key reference to another table. We've said that it was a foreign key reference to another table, and we were referring to the trainer, and we were referring to the column name. I'm going to make a change to the Pokemon table. I want this to happen outside of a transaction. This is something that I would normally do when I'm making the table in the first place. I'm going to recognize that I'm going to have to be in situations where I need to have this temporary disabling of my foreign key constraints. So this is something I would do in DDL and not as an alter table statement. But I'm going to do an alter table statement here. I'm going to say alter table Pokemon. And what I want to change about the Pokemon table is I want to say that the foreign key constraint that we have here should be deferrable. And what that really means is I want to be able to insert records in a transaction, and only when the transaction is attempted to be applied should you do the foreign key constraint checking. So my data will temporarily be inconsistent in the form of the foreign key constraints that I've got, but that's okay. I understand that to be the case. So I want to alter my table Pokemon, and what I specifically want to change is I want to alter a constraint. The constraint that I want to change is the one that is being printed here. So it says Pokemon underscore trainer underscore F key. We can give these foreign key constraints our own names. This is what's generated by Postgres when it creates that for us if we don't specify the name. And so we're going to use that. I want to alter this constraint Pokemon trainer F key. So I want to make changes to the constraint itself. And the way that I want to alter it is that I want it to be deferrable. So really what I'm saying is, I still want you to have this as a foreign key, but in circumstances like I'm in the middle of a transaction or I have turned off these foreign key constraint checks temporarily, I want you to let me insert things that will temporarily violate these foreign keys for a little bit, and then I'll turn them back on, and I want you to check. So let me do this for a little while, but after I'm done, you need to tell me, the database management system, that this is or is not in an invalid state. So I'm going to change my table now to have this deferrable property on it. I'm going to start a transaction. And then what I need to do is I need to temporarily disable foreign key constraints for the Pokemon table. I need to temporarily disable these foreign key constraints. And the way that I'm going to temporarily disable these foreign key constraints is to say set constraints. And I'm going to use that same name, so Pokemon underscore trainer underscore F key. And I'm going to say that I want this to be deferred. So when I altered the table, I said, I want to be able to turn these off. And now I'm saying, I want to turn them off for now. And I'm going to ask you to check them eventually, but for now, please just let me do this with the understanding that the foreign key constraints might be violated. And so I will try the same insert statement. So insert into Pokemon a nickname and a trainer, and I've got this kid's value. We've got two values in the trainer table right now. We've got Franklin and we've got Walter, but we do not have kid. So that foreign key does not exist. But I've temporarily disabled those foreign keys. And so if I select star from Pokemon, for now, that's in there, in the transaction. And if I select star from trainer, I don't have a value, I don't have a row in this table that's got that foreign key value that is kid. So I've got those things set up. I have this temporary situation where my foreign key constraints have been violated. But when I try to commit, it will not let me. So temporarily disable them. Hey, I've kind of inserted it inside this transaction, but when I try to commit, it forbids me from doing that. And if I select star from Pokemon again, that change hasn't happened. It hasn't actually inserted that row. We started a transaction, we disabled foreign key constraints, we inserted something that violates foreign key constraints. We said I'm done my transaction, but that violated foreign key constraints. Nothing has happened, nothing has changed. If I were to do this again, so I'm going to begin a transaction. I'm going to temporarily disable my foreign key constraints. I'm going to insert into Pokemon this kid reference. And I'm going to insert into trainer name, balance, team count, values, kids. Kids these days get more money from their parents, and they have one Pokemon. And if I select star from trainer, and if I select star from Pokemon, we now have consistency across our two tables. And so if I commit here, it's fine. It's going to apply all of those operations. Our foreign key constraints are back on. If I try to insert other kids into here, so we're going to say that other kids also is trying to catch Fire Moon. It's not going to let us do that because we still have foreign key constraints on the tables that we've got. All right. Okay. So are there any questions about this? Okay, cool. So at this point, you should be able to model relationships between data model objects in a database. And very specifically, you should be able to use transactions now. You should be able to describe the idea of what a transaction is accomplishing. So like making sequences of statements atomic, they will either all be applied or none of them will be applied. You can use them for things like temporarily disabling foreign key constraints so that you can temporarily violate foreign key constraints and then commit them, and they will either entirely be applied or they will not be applied. There's no situation where they're going to be half applied as a result of this. This also means you should be able to do things like define and describe the idea of what atomic is in the context of a database management system. So again, it's either all applied or nothing is applied as a result of the statements that we've got. That's it for today. I hope that you all have a great long weekend. I will see you next week on Tuesday for a review and for talking about the exam. And that's it. Have a great weekend. Bye, everybody.